Well, we're trying to find if it's absolutely convergent or conditionally convergent or divergent. So I think, do you think it would be a good idea to start with the divergence test?
Yeah, we could do that, but here, I mean, so is the limit of this thing 0?
Yeah.
Yeah, so that doesn't tell us anything. So we're done with that.
Oh,
But
okay.
I think it's a good thing to do. Like if you have a series, you look at something and the limit is not 0, then you're like diverge is done. But if the limit is 0, then we have to do more work.
Okay. Um, okay, so then the limit of this is 0. So then that means that it's wait. So then what does that mean again?
So yeah, this is really really important thing. So if we have a series, if it converges, then we know that the limit n goes to infinity of a and has to be 0. That is true. But now the other direction doesn't work because there's the harmonic series. So this is one
Right.
of the dangers. So if the limit is 0, it doesn't tell us anything, like anything at all. We don't know anything. It might converge, it might not. Like, it converges on Fridays. I don't know. Sorry, that's really bad. uh, yeah, the worst thing to laugh at your own jokes. I mean, okay, so at least my work is fun, so Um, good. So we don't know anything. If the limit is 0, we just don't know. We have to do some more work.
Okay.
Yeah.
And then if the limit is not 0, then it diverges.
Then it diverges. Like let's say the example of like let's say n from 1 to infinity of just 1. Like what are we doing? 1 plus 1 plus 1 plus 1, and then you just keep adding the blocks. 1, 1, 1, 1, 1. Like you just keep going like to infinity.
Okay.
And here the limit is 1 because it's just a constant. Yeah, so if the limit is not 0 or it doesn't exist, then we know diverges. And that's it. We're
Oh,
done.
okay. And then what would the case be with like conditional convergence?
This doesn't tell us anything about that.
Oh. So then like what in what case would something be conditionally like what's an example of something that would be like conditionally convergent?
This is really not the divergence test. This is just truth. Like if a series converges, then the limit is 0. This is the divergence test. If the limit is not 0 or doesn't exist, then we know that the series diverges.
Got it.
Like it's just kind of like like what would be a stupid everyday example of this, like probably not a good example, but like if it let's say if it rains, then my hair is wet. Now if my hair is not wet, it means it cannot rain, but I mean, of course I could have an umbrella or whatever, so that's why it wasn't such a good example, but it's kind of, you just turn it around.
Okay. Okay, that makes sense. Um,
Yeah. Like let's say I have a job, I get money, and if I don't have money, then that means I don't have a job, or something like that. It's
oh,
just kind of
okay.
like turning the whole thing around. This is really common in like magic.
Like all
Magic.
squares are rectangles, but not all rectangles are squares, like that kind of thing.
Yeah, I think you have a similar point there. Like if a shape is a square, then it's a rectangle. So if a shape is not a rectangle, it cannot be a square either, right? That kind of
Mm-hmm.
thing. Yeah, good. So now back to your question, what did you ask? And I almost forgot what it was. So example of conditionally convergent things.
Yeah.
I think the famous one is just the alternating harmonic series. So n from 1 to infinity, -1 to the n, 1 over n. Here, the limit is still 0. because the negative one to the n, it doesn't, it just like bounces, but it starts to go towards 0.
Well, what does conditional convergence even mean then?
It means that if we, this is converges conditionally because why? Do you remember the definition?
I don't. I have it in my notes somewhere.
Yeah, because basically it's kind of a border case. If we take absolute values, so if we take absolute value of the inside, we get what?
If you take the absolute value of the inside, then you just get 1 over n.
Exactly. So we take the absolute values, which is exactly as you said, just the series 1 over n. This diverges. So basically, this original series converged, but if we take the absolute values, it doesn't. So it's kind of a borderline, like it required the negative signs there.
Okay, so for this problem, like the one above a little bit. So we have that the limit approaches 0. So the divergence test doesn't tell us anything. All we know is that it doesn't diverge. So then,
so we don't know it converges yet.
right.
That's really good point to stop here, because if the limit is 0, could go either way, because we have, so this doesn't
it could,
tell.
okay.
Yeah, this doesn't
So we don't know
tell anything. And I think this is a really important point. If the limit is 0, we don't know, because we have, like, let's say, n from 1 to infinity, 1 over n squared, which converges. But then 1 over n, which doesn't. Both have limit to be 0. Like, this just doesn't tell us anything, unfortunately.
Okay.
What matters the most?
So what matters the most is the end of the fifth.
Yeah, and on the top is the what?
End of the third.
Yeah, so I would say this is a good strategy. This is like about this for large n. So these are the things that matter. And what do you know about this?
That equals n over n squared, or 1 over n squared.
1 over n squared. Yeah, and what do you know about series, the series? 1 over n squared.
Converges.
Converges. Okay. So now, what would you expect for the original problem?
So because it's basically the same, then the other one converges.
Yeah, and I would say probably you would not get full credit with that answer, so you would have to do a little bit more work. Probably.
Okay.
I mean, I'm not grading it, so
No, I
who
think
knows?
you're right.
Who knows?
So what did I put as the answer for this one? So I used the limit comparison test for this.
Yeah, so why can't we use the direct comparison test is the following. So basically, let's try to go from n cubed over n to the fifth to this form. So now if I add the top, add the n to the top, what happens? Which one is larger?
Then the first one's larger.
First one is larger because I made the numerator larger. Good. How about if I add stuff to the bottom instead? Oops, n cubed over n fifth plus 4n squared plus 1. What does that do?
So then the one on the right is larger because it's a smaller denominator.
Yeah, exactly. We made the denominator bigger. So this is a problem, because now if I just want to kind of compare, now if I put stuff in the denominator, I make it smaller. If I put stuff in the numerator, I make it larger. So they go in different directions. That's why we cannot do direct comparison. So basically, let's look at this one, the first one. So now if I have something that converges and then something that's greater, can I conclude anything for that one?
No, it has to be under it. It has to be
Exactly. So
smaller than.
I wouldn't be able to conclude, but for this one, this converges, that's smaller. And I mean, there's the greater than 0 because now everything's positive here. So we would be able to conclude that this converges, but now the other comparison goes in wrong order, wrong direction. So that's why we would have to use the limit comparison test.
So basically, we can use limit comparison test. So we say that the limit of n approaches infinity. So a sub n would just be what, n cubed over n to the fifth plus 4n squared plus 1?
So this original one, right?
Oh, the original. Okay.
Yeah. I mean, that's what we're interested in, because these comparisons didn't work for the actual thing. Good. And what else do we need?
And then what, b sub n, which we're comparing it to, so it's just 1 over n squared.
Yeah, and then we divide, right? So I'm just gonna do this. I'm not gonna keep writing the lim because I'll forget anyways. So n, yeah, you did n cubed plus n over n fifth plus 4n squared plus 1 times n squared over 1. Good, and then you got the n fifth plus n cubed over n to the fifth plus 4n squared plus 1. Okay, and then we can do what?
So then we can just divide both the top and the bottom by 1 over n to the fifth.
Yeah.
The leading term.
Yeah.
So then this is just, I think it's just 1. It's 1 over 1, which is just
1. Good.
Yeah.
Plus
1 plus n cubed over n to the fifth.
Yeah.
Over 1 plus 4n squared over n to the fifth plus 1 over n to the fifth.
Can we still
And then,
simplify?
so those three terms cancel out. And then you just get 1 over 1, which is 1.
Terms. Okay, no. You're a little sketchy math here. So what is this?
That's 1 over n squared.
Yeah, exactly. So a little bit more. Like, I would not be happy as a grader. You just said, oh, they just cancel. No.
Oh, okay.
So what is this?
4 over n cubed.
Yeah, and the last one was good. So now what happens to them? They don't cancel, but what happens?
Sorry, I didn't mean cancel. I meant they go to 0.
They go to
They turn
0
into
when
0.
Yeah, exactly. They go to 0 when n goes to infinity. Exactly. N goes to infinity, we get what?
We get 1.
We get 1. Now what does that mean?
That means that the ratio between the two functions is just 1, right? So that means that it basically, as n goes to infinity, the two terms are going to basically do the same thing.
Exactly. So it's exactly what we did here, but a little more mathematical. So this is kind of almost this for large n. So the farther we get the limit, the ratio of these two things, which we just calculated here, is going to be closer and closer to 1, which means this is going to be closer and closer to this thing. Good?
Got it. Okay.
And now for what is the conclusion? The limit was 1, so what do we know?
So we know that because 1 over n squared converges, absolutely, the original function or the original series also converges. Absolutely.
Except I think the absolutely doesn't. No. You're right, because I think pretty sure we have to take the absolute values. Yes. So if we put the absolute value, we get something that converges. Yes.
Got
Good.
it. Okay.
So converges is the conclusion. And here, what was crucial, it was not that it's 1, it could have been 2 as well, but it should be a finite number.
Right. And if it's 0, then what does that mean?
If it's 0, let's think about, then it would mean that this is much bigger in some sense. So we divided by this thing. Now we know this thing converges. So now if we get 0 as the limit, then I know this stuff is bigger, but it still converges. So now I would kind of use the regular comparison test.
Okay.
But that might not be part of the kind of how it's usually stated.
Right.
Yeah.
Okay. That makes sense.
Yeah, and I mean, yeah, and as you said, converges not conditionally, absolutely, because we just kind of, like here, if we take absolute value, it doesn't change anything. So this thing cannot converge conditionally because the series itself is the same whether there's absolute values or not.
I see.
Mm-hmm.
That makes sense.